All right, this is 7-2 notes. So here for 7-2, you're going to divide. So we're going to go ahead and get started. First thing I'm going to do is I'm going to write over here. Okay, I'm going to make a little note. Actually, let me go ahead and zoom back out. We're going to make a little note that whenever you divide, you subtract exponents. And if you hear Mickey in the background, that's because Brenham is currently watching Mickey Mouse while I try to get this video done. So we'll see how much I can do without her crying. Okay, so here we go. Number 1. All right, so we're dividing. So what we're going to do is we write our base, and our exponents we subtract. So we have 5 minus 4. So you have 6 to the power of 1. And that's your final answer. All right, number 2. Okay, same type of thing. We have our base of 9. Exponents are 12 and 8. Since you divide, you subtract them. So 12 minus 8 is 4. Sometimes they ask to give the whole number, so 9 to the 4th power. Okay, so I'm going to put or. 9 to the 4th power is 6,561. Okay, so just depending on what they ask, 9 to the 4th power can be the answer, or your whole number can be the answer. Okay, number 3. So for this one, my base is x. And then we have 4 and 2 for my exponents. So since we're dividing, we subtract. 4 minus 2 is 2. So that's your final answer. Okay, number 4, we have 2 different bases. First one is r. So we have 3 minus 3. And the next one that we have is t. My exponents are 2 minus 4. Okay, so here, 3 minus 3 is 0. And here, 2 minus 4 is a negative 2. We have 2 really important things here. Okay, first thing, anything to the 0 power. Okay, so anything to power of 0 is always 1. So this right here is 1. Okay. Second important thing is anytime you have a negative exponent, so negative, bless you, baby, negative exponent, okay, you have to put it in the denominator, okay, so it goes in the denominator, let's see if I have space, denominator, and it becomes positive when you move it in the denominator. So what this is going to be, okay, is 1 over t squared. Well, you don't need this 1 out in front, so your final answer is just 1 over t squared. All right, and we'll get to some more problems like that here in just a little bit. Here we go, number 5. So for this one, remember if they don't have a exponent, I'm going to write that in there. So this is m to the power of 1. So I still have my base of m. I have 1 minus 3. 1 minus 3 is a negative 2. You don't want negative exponents. So what you do is you put this in the denominator to make it positive. And again, you can always pause, rewind, anything if I go too slow. I'm just trying to get this done before we have a crying baby. All right, so next one. We have 9 divided by 3, which we're going to just divide like normal. And then we have d. My exponents are 7 minus 6 because whenever you divide, you subtract your exponents. 9 divided by 3 is 3. And d, 7 minus 6 is just 1. And that's your final answer. Now, if you write your answer like this, okay, so if you want to write your answer as 3d, I'll still take that. Okay, either one of those is correct. All right, here we go, number 7. So for number 7, we have 12 over 36. So we're still going to divide those because they are not exponents. Here, this n has a power of 1. So what I have is n 5 minus 1. Okay, you can type in your calculator 12 divided by 36 and hit math and enter. And that comes out to 1/3. So we have 1/3. And then we have n, and we have 5 minus 1, so 5 minus 1 is 4. You can also see this written as n to the fourth power divided by 3. Okay, both of these are the exact same thing, and I would accept both answers. You just need to make sure you recognize both ways that they can write it for your EOC. Okay, number 8. So we have two different variables. So the first one I have is w, so we have 4 minus 4. Okay, if you look for x, remember this is to the first power. So my next one is x, 3 minus 1. So we have w to the power of 0. And we have x, 3 minus 1 is 2. Anything to the power of 0 is just 1. So this is 1, and that's x squared. So that's just the same thing as just plain old x squared. And that's your final answer. All right, number 9. Again, we have two different variables. I'm going to go ahead and put the 1 here for my a. So we have a, 3 minus 1. And we have b, 5 minus 2. So we have a, 3 minus 1 is 2. We have b, 5 minus 2 is 3. And that is your final answer. All right, number 10, two different variables again. So I have m, 7 minus 3, and we have p, 2 minus 2. So m, 7 minus 3 is just 4, and p is 2 minus 2 is 0. So again, that's just to the power of, anything to the power of 0 is always 1. So really our final answer here, make this red. Our final answer here is just n to the fourth power. Okay. All right, number 11. So first I just have my normal constants, negative 21 divided by 7. Then I have two variables. We have w, 5 minus 4. And then I have x, 2 minus 5. So here, negative 21 divided by 7, okay, is just negative 3. So we have negative 3. And then we have w, 5 minus 4 is just 1. And then we have 2 minus 5, which is negative 3. So remember, you cannot have this negative exponent. So what we're going to do is we're going to rewrite this. So I'm going to write it all as one color. So that's equal to negative 3. And then you have your w. This x to the negative 3 power, all that goes to the bottom. And when it goes to the bottom, it becomes positive. So that's your final answer. Alright, and number 12. So again, we have 32 divided by negative 8. Okay, I'm going to go ahead. I need a 1 for my x, 1 for the y. So we have three different variables. So we have x, 3 minus 1. We have y, 2 minus 1. And we have z, which is 5 minus 2. Okay, so 32 divided by negative 8 is negative 4. We have 3 minus 1, which is 2. We have 2 minus 1, which is just 1. And we have 5 minus 2, which is just 3. So again, you can write it like that, or I'm going to rewrite this as one whole thing. Negative 4x squared, y, z to the third power. You can write it like that because 1 is kind of like your invisible number, so you don't have to write it. All right, let's see. Okay, number 13. So you have a 2 out here. First thing you have to do is you're going to have to distribute this 2 to everything inside. Everything inside. So I'm going to rewrite this. So we have 4 squared. We have p, 7 times 2, because we have a power to power, we multiply. Okay, on the bottom we have 7 squared. And then we have r, let's see, and then we have power to power, so we multiply. Okay, so I'm going to reduce this. 4 squared is 8. Okay, 7 times 2 is 14. There's red. 7 squared is 49. And then for my r, 2 times 2 is 4. Okay, now here's the thing. You can type in your calculator 8 divided by 49 and hit math enter, and it just comes out to 8 over 49. So that doesn't reduce. You can't do anything with the subtracting of those exponents because they're two different bases. One is a P and one is a R. So this is your final answer. All right, number 14. 4 to the power of negative 4. We're going to rewrite that. It's a negative exponent, so we're going to put it in the denominator. And so then that just comes out to 1 over 4 to the power of 4 is 256. And that's your final answer. And you can always put that in your calculator, 4 to the power of 4. All right, next one, so same type of thing. We have a negative exponent, so it has to go in the denominator. And then we're going to reduce that. 8 squared is 64. So we have 1 to the divided by 64. Okay, 16, same thing. First, there's a couple ways you can do this. We can distribute this negative exponent. So we have 5 to the negative 2 over 3 to the power of negative 2. Now what we're going to do is we're going to flip-flop this. Okay, and the reason why we're going to flip-flop it is because when you flip-flop these, it changes the sign on the exponent. So what we have is 3 squared over 5 squared, and then we can reduce that. So our final answer, 3 squared is 9, 5 squared is 25. And that's our final answer. And that doesn't reduce. If it reduced, we would write that. But since this doesn't reduce, that's our final answer. Okay, same thing that we're going to do here. So I have a negative 1 to distribute to both. So we have 9 to the power negative 1, 11 to the power negative 1. To get rid of the negative exponents, we're just going to flip-flop these. So that becomes 11 to the power of 1, 9 to the power of 1. 11 to the power of 1 is just 11. 9 to the power of 1 is just 9. You cannot reduce that, so that's your final answer. Okay, number 18. So here, okay, you have this negative 6 that needs to be brought up so that it's not it's not negative anymore. Bless you, baby. So you have h to the 3rd power times h to the 6th power. So that's just adding those because we're multiplying now. So my final answer is h to the power of 9. There we go. All right. Okay, here we go. Number 19. So we still have the same base, that's k. Here when you multiply, we add. So you have 0 plus 4 plus 6. When you add all those up, it's just k to the power of 10. And that's your final answer. Okay, number 20. So again, we have the same, we have different bases, right? But I have two negative exponents. So I have this negative one and that negative. So what we're going to have to do is we got to put those in the denominator. So what's left that doesn't need to go to the bottom is this m to the 3rd power. So that's going to stay up top. And on the bottom, okay, it's going to be k to the power of 1 and l to the power of 6. Now, remember, you don't have to have the k to the power of 1. So really, you can write your answer, m to the power of 3 over k times l to the 6th power. And that's our final answer. All right, number 21. So again, I have this negative exponent that needs to go to the bottom. So don't forget, though, you still have a 1 on top. So on the bottom, I have f to the power of 7 times f to the power of 4. So we still have the 1 on top. Down on bottom, okay, we have f 7 plus 4. So your final answer here is 1 over f to the power of 11. And that's our final answer. All right. Number 22 looks really complicated, but here is the important thing. It's to the power of 0. Anything to the power of 0 is just 1. So those are nice problems to do. Okay. Number 23. So here again, I got a couple of things I got to move. I'm going to have to flip-flop these two to get rid of the negative exponent. So there's a negative, there's a negative. We're going to flip-flop these. So this h to the negative 2 power is going to go on top, so h squared. G to the fourth power is still going to stay up there because we didn't need to move it. And then what goes on the bottom is going to be this f to the fifth power. So pretty much what these is, if you see a negative exponent, you just flip-flop with the location. So if it's in the numerator, you put in the denominator. If it's in the denominator, you just put in the numerator. These are all different bases, so that's my final answer. Okay, number 24. So I'm going to go ahead and rewrite this. 15 divided by 5. We have x 6 minus, now don't forget, here you have the exponent of 1. So 6 minus 1. And then we have y. We have negative 11 minus, okay, negative 11. So here when you have a minus and a negative, it becomes a plus. So I'm going to reduce this. 15 divided by 5 is 3. 6 minus 1 is 5. And negative 9 plus 11 is a positive 2. And so that's our final answer. All right. Okay, last two. So here I'm going to rewrite this again. Negative 15 divided by 5. This t to the 0 power, that's just a 1. So pretty much you're going to ignore that. And then we have u. We have negative 1 minus 3. Negative 15 divided by 5 is negative 3. Okay, and then negative 1 minus 3 is a negative 4. You can't have negative exponents, so my final answer here is going to be negative 3, and I'm just going to put this in the denominator, so u to the fourth power. That's how we change the signs on the exponents. All right, last one. We have 48 divided by negative 6. Okay, then we have x 6 minus 1, so don't forget that's a 1. Then we have y 7 minus 5. And then we have z 5 minus 6. Hang on, baby. So we have 48 divided by negative 6, which is negative 8. Oops, wrong color. So that's negative 8. We have x 6 minus 1 is 5. We have 7 minus 5, which is 2. And then we have 5 minus 6, which is a negative 1. Okay, so remember, you can't have the negative exponent. So your final answer, and I'll rewrite it, is going to be, let's see if I have space. Yep, I have space. Okay, so final answer is going to be negative 8, x to the fifth power, y squared. All of that is divided by z, because we got to get that negative exponent gone, so we put it in the denominator. And that is your final answer. All right, so that's your 7-2 notes. I don't think there's any more. Nope, that's it. Okay, so if you have any questions, just come see me.